Today we're going to do some practice with oxidation reduction reactions, which are also for short called redox reactions. Remember that this mnemonic says oxidation is loss of electrons. Keep in mind that when you're looking at that, it's not oxidation is loss, it's loss of electrons, which means that you're becoming more positive. Reduction is gain, so that means when you're reducing, you're actually becoming more negative. Okay, let's do a couple of practice problems. In each reaction, you're going to have something that's oxidized and something else that is reduced so that the balance of electrons altogether even out. If you look at cesium altogether, it has just a 0 oxidation number, and bromine gas also has a 0 because it's not giving or taking electrons. But if you look at the combination of cesium and bromine, if you look at the periodic table, has a -1 charge. And if you look at cesium, which is number 55, it has a +1 charge. So cesium goes from 0 to a +1, so it's oxidized. Okay, it lost an electron. And bromine goes from a 0 to a -1, so it's reduced. Okay. Here we have chlorine as a 0. Sodium is a +1 from the periodic table. Bromine is -1, +1, and -1, and this is a 0. So let's take each one. Chlorine goes from a 0 oxidation state to a -1, so it's reduced. Sodium goes from a +1 to a +1, so it doesn't do anything. It's called a spectator ion. It's not actually reduced or oxidized. And then bromine goes from a -1 to a 0. And if you think about that on a number line, then from a -1 to a 0 is actually going up. It's more positive. So bromine is oxidized. Okay. Let's do a little practice here. Let's give the oxidation number of each atom or ion. A sulfate, if you look on the periodic table on the back, is a -2. Tin all by himself is a 0. He's just like a tin cup. Sulfide ion is a -2. This iron ion is a -3. This tin happens to have a +4. It can be it's one of those it's not really a transition, but it acts like that sometimes. Nitrate, if you look at your polyatomic chart, has a -1, and ammonium on your polyatomic chart has a +1. That's how you find those. This poses a bit more of a challenge if you have atoms that are bonded in compounds. So in this one, you could look at this and know that when you reverse crisscross, chromium had a +3 and oxygen had a -2. That's how you bonded those two together. So chromium in this, they really just want the chromium. Chromium has a +3 charge. This one's a little more challenging. I'm going to write it larger so it's a little easier to see. Okay, each one of these oxygens has a -2 charge. You have 7 of them, so that's a total of -14 electrons being gained by the oxygens. Each sodium is a +1. If you look at the periodic table, you have 2 of them, so you have a total of 2 electrons being given away by sodium. So in order for the whole thing to be 0, you need to find out what chromium is. Well, there's 2 chromiums, so you can turn this into an algebra problem. 2 times whatever the value of chromium is going to add up. So if you look at this, you have a +2 plus 2x minus 14 is equal to 0. Okay, so that gives you 2x minus 12 is equal to 0. So 2x is equal to 12, x is equal to 6. So each chromium is going to contribute a +6 or give away 6 electrons. Here you have a polyatomic ion, which is a -2, so that means that chromium must be a +2 because the total is equal to 0. If you look at your polyatomic chart, chromate is CrO4, -2. Now in this case, it's not going to add up to 0 anymore. The charge of this ion is a -2. So the total charges of oxygen plus the total charges of chromium are all going to equal a -2, not 0, because it's not a compound that just has a 0 charge. So each oxygen has a -2 charge. You have 4 of them, so a total of 8 electrons being given or taken for the oxygens. Chromium has to have something in order for this to balance. So you have an x minus 8 equals to 2. So x is equal to plus 6. Now if you look on your chart, dichromate looks like this. Again, the total charges will equal to -2 because that's what the charge of the ion is. Each oxygen is -2. You have 7 of them, so you have a total of -14. There's 2 of something, 2 chromates to equal this, so 2x minus 14 is equal to -2. 2x is equal to 12, so x is equal to 6. Okay. All right, now let's look at a reaction and see who's oxidized and who's reduced in the reaction. Carbon has a 0 oxidation number here. Each hydrogen has a +1, but there's 2 of them for a total of +2. Each oxygen is a -2. You have 4 of them, that's -8. So altogether it has to equal 0. So sulfur is an X, it's the unknown. So 2 plus what number? -8 is equal to 0. So that means that sulfur has a +6 charge. It's kind of unusual. You normally think of sulfur as -2, but depending on who he's bonding with, he can also be a +6. If you look on the periodic table, you can count that over. It makes sense. Over here, each oxygen's -2 times 2 is -4. It has to balance. There's the same number of electrons are being taken as given, so that means carbon must be a +4. Okay. Here you have each oxygen's -2 for a total of -4, so sulfur in this case is a +4. This is a -2, each of these is a +1. Okay, that balances. All right, so let's look at what's oxidized. Remember, oxidation is loss of electrons, but you're becoming more positive. Reduction is a gain of electrons, and so you tend to become more negative. All right, so looking at this, carbon goes from 0 to a +4, so he's oxidized because he's getting more positive. He's losing electrons. Hydrogen goes from +1 to +1, so he's just a spectator. Sulfur goes from +6 down to +4, so he's reduced because 6 goes down to 4. He's reduced. Oxygen stays the same as well. So let's look at this one. Each oxygen is -2. I'm going to erase some of this so we can clean it up a little bit. Okay, so 2 times 3 is -6 altogether. Hydrogen is +1. There's only 1 of him. So for nitrogen, for everything to balance out, that means nitrogen must be a +5. Okay, hydrogen is a +1. Iodine is a -1. Oxygen is a -2. Nitrogen is a +2. This is a 0. -2, +1, and +2. I think you're getting the idea. Okay, so let's look and see what's oxidized. Okay, hydrogen goes from +1. It's still a +1, and it's still a +1. He's a spectator. Nitrogen goes from +5 down to +2, so he is being reduced. Oxygen, -2 to -2. Let's look at iodine. He goes from -1 up to 0. Now be careful because you might think of it that it has to be positive, but that's not the case. When you go from -1 up to 0, you're becoming more positive. You don't necessarily have to be positive. So you're losing electrons, which causes you to become more positive. That's how you do those kinds of problems. Now let's stop down here for just a moment. There's an oxidizing agent and a reducing agent. Don't be confused by thinking that the oxidizing agent is the thing that's being oxidized, because that's not true. An oxidizing agent is the one that it allows the other to be oxidized. It's just like an agent in sports, maybe a sports agent um, negotiates a better contract or allows more playing time or something to that effect. And so that's what's happening here. So if you look at this first equation, carbon is being oxidized, but he's actually the reducing agent. And the reason is because he's losing electrons, and so he's an agent for sulfur to become reduced. I know it's a little bit backwards. Sulfur is the oxidizing agent because sulfur is an agent representing carbon that allows carbon to become oxidized, okay, because he gained electrons. All right. So in the case of this one, iodine is the reducing agent because he's oxidized, and nitrogen is the oxidizing agent because he's reduced. Now let's get going with these half reactions. A half reaction basically includes electrons. All right, let's do 10-2. 10-2 is going to 10-4. He's being oxidized, so oxidation is loss of electrons. So he's going to lose some electrons. How many does he lose? Well, he goes from 2 to 4, so he must be losing 2 electrons. Okay, iodine, if you look at this, this is a -2. 2 times 3 is -6. Okay, that means that iodine over here is a +5. All right, I just did the balance there. Here he's a 0. So iodine goes from +5, and he has to gain electrons. Reduction is gain to get an oxidation number of 0. Now, how many electrons would he have to gain? Well, since he went from 5 up to 0, he's going to need 5 electrons. Now, in order to balance these, you need to have the same number of electrons lost as you have gained. So I'm going to multiply this one times 5 and this one times 2 because that's my least common factor, or least common multiple. All right, so then we'll rewrite this. 5 SN2s will make 5 SN4s plus 10 electrons. And then I'm going to multiply the bottom one by 2. 2 I5s plus 10 electrons will make 2 I's. Now I need to add them all together because those are my 2 half reactions, but now I want to complete it and balance the whole thing. So this tells me, I'm going to clean this out a little bit. This tells me that I need altogether 5 SN2s, all the reactants go on one side, plus 2 I's plus 10 electrons will yield 5 10-4s plus 10 electrons plus 2 I's. My electrons cancel. Sometimes they keep them in there, sometimes they don't.